Okay, we may start. First, thank you for coming to this presentation around continuous delivery and Docker. To introduce me in a few words, I'm working for Société Générale on a continuous delivery transformation program, mostly focused on DevOps topics, which means automation, collaboration between Dev and Ops. And I'm here today to share with you a perspective in which Docker could be something quite useful to move to continuous delivery. Well, prior talking about continuous delivery or even continuous deployment, there was the agility. It was interesting. It was enabling to deliver, to produce frequently application artifacts, but finally it was useless for the business because you can bring value for your from your application only when it's in production. So the challenge was to push your assets from this application software factory up to the production. So to summarize in a few words, finally, continuous delivery is just only about prolonging the agility up to the production. The problem is when you say this, it has several implications. The first one is you no longer just have to focus about your application. You just have to embrace the environments on top of which your applications will have to run to. And so it means you have to address infrastructure configuration, middleware setups, etc., at industrial scale. But it also means that it's not only a technical problem. You also have to now embrace the ops people which are behind these problematics traditionally. So it's a problem also of collaboration with these people. There are some new solutions which are pushing on the market about organization. We can speak about feature teams, DevOps cultures. There are also some changes in architecture of application, and we have also a lot of tools enabling automation of the delivery. We can speak about a configuration tool like Puppet. We can speak about cloud features which are now managed programmatically, etc. But now there is Docker. And the idea is put Docker as our central piece for delivering our applications. The idea is that Docker finally proposed two things. It's firstly the container paradigm, in which you can onboard your application and all its subsequent infrastructure configuration in it. But it's also providing the platform in which you will run your application containers. And the point is, saying this has several implications, because the containers have really particular features. The first one is about portability. The container could be run on different kind of platform without having to care about the specific stuff about this platform. It's also programmatic, versioned, immutable, but we'll dig into this progressively. What containers are not? It's not virtualization. Virtualization is about having a whole operating system onboarded, emulating its underlying hardware. But in the container world, it's just about pushing a dedicated file system and your application and subsequent requirements, such as a middleware, in an isolated manner to run it on a shared server. When addressing the continuous delivery part, the idea is to state that this container will be your central piece, being your new universal application artifact. In fact, when you are delivering applications, the things you are not doing is pushing just a few parts of your application on the servers, changing a class, changing a DLL or something. You don't do this because when you are doing this, you may change the setup, making it not idempotent, since you may have problems like during this deployment. And finally, your applications may be unstable. The idea is to make something which is immutable, onboarding the application and all its subsequent infrastructure configuration. And this will be immutable. That means that if you have to change your infrastructure configuration, or if you are changing a single line of your code, you are rebuilding this artifact and you are pushing it on your platform. You are no longer patching or changing your configuration in the container. Saying this has several implications. The first point is it implies that you are merging the application and its subsequent infrastructure configuration. It means that you no longer have teams which are responsible for delivering the applications, other teams which are responsible for managing middleware, configuration, infrastructure. You can do this because, in fact, you are enclosing all of this in the same artifact. It means that you must conduct your patch management differently. Traditionally, in companies, people responsible for applications are managing their pipelines, they are managing their deployments, and some other guys which are on the upside are only concerned about patching systems, changing libraries such as OpenSSL, etc., etc. Now, saying this means that should you are wanting to change a single line of code because you have a new feature you are delivering, or should you have an infrastructure library changing, it means you are redeploying this whole application artifact. It's really merging the life cycle of this object, and it implies so that application developers and infrastructure guys are working jointly to ensure that this product will move into the pipeline and will be delivered correctly on the environment. Well, saying that the container contains an application and is immutable, meaning that you are rebuilding a new version of this container when you want to change its content, it also means that you will trash the older version of the application. And so it means that the data of the application should be externalized out of this container. There are several ways to do this. But when you have to use file systems for legacy reasons, because in new applications, it's better to use some different kind of solutions, such as object storage. If you need file system, you can use Docker volumes to ensure that finally you will mount in your application containers the file systems of the data you want to persist, but it won't be stored directly in this container. So when you are promoting a new version of the applications, you will just mount your persistent data in the new version of the container. You also have to handle configuration and globally everything which could be variable outside this container, because we want this container being the same object deployed on the different environment you use, on development, on UAT, on production. Because in the application world, you do not want to rebuild your application per environment, because it's not repeatable. It does not ensure that the application will work the same way on all your environments. So in this way, you ensure that the applications the application containers only contain the application itself and no data, no configuration, nothing that could change or nothing which should persist in the applications across versions. Docker is not only about technical stuff. It's also changing the way people are working around it. I just took an old quote from Mr. Conway in 68, which is finally still true today. Because in fact, the point is, today, if you want to use the container correctly, I just thought that it's important to push together all people involved in the content of this container. So it means people developing the application, but it also means people which are responsible for traditional configuration of the middleware, etc., etc., etc. And in this way, we propose different kind of setups. The idea, finally, is to have on one side some teams which are responsible for their application. These teams are multidisciplinary. There is some developers, there is some ops, business analysts, etc. And all these teams are working jointly to build and run these applications. And these teams are focused on building these artifacts, and they are concerned about how the application inside the container is working. However, the traditional infrastructure teams are now focused on something different, which is how I gonna host the containers I have to run for the application teams. I'm not concerned about the internal content of these containers, but I have to run mass of containers for different application teams. So it means that you have dev and ops people on one side in the application team, but you have also dev and ops people in the other side, in the infrastructure team. From the platform point of view, now we have applications having containers. The point is how and where do I host them? The point is, finally, historically we had IaaS cloud. It was just infrastructure commodity, having virtual machines on the cloud, for example. There was also several definitions of the PaaS. But finally, Docker created something which is intermediate, which could be named the CaaS. The point is, the CaaS is between the two clouds, IaaS and PaaS, because it takes from the IaaS the infrastructure view, because inside a container, you are creating file systems, you are pushing libraries, you are running a binary application. So it's close to the IaaS, finally. But it's also close to the PaaS because you are not sticky to the infrastructure server themselves. You have created portability, you are agnostic from the subsequent server on top of which you are running. And so it's a kind of new product the infrastructure teams have to run. This is something they can manage locally on their side. For example, they can integrate a commercial product such as Cloud Foundry or OpenShift. It could be something which is based on the Docker platform itself. Swarm cluster is raising on the market. But it could be also something they are taking from the cloud. For example, Amazon ECS is providing CaaS services directly out of the box. So you do not have to care about the plumbing, finally. An additional point, which is quite important in traditional companies. The point is, the application team is involved on creating the containers it needs to run. But most of the time, the images in which the Docker images in which they will put their application have to be delivered by a trusted team, which comes from the infrastructure. It's originally the people which were responsible for delivering the images for virtual machines or physical systems. So finally, they have to produce a new kind of object, which is a base Docker image, having the simple file system of an operating system, on top of which application teams will be able to put their own payload. They can also provide directly running services that application teams can use directly without having to dig into. For example, if an application team needs a MySQL database, it's not their job finally to create a MySQL server, but they would be able to start and run a MySQL instance which is being delivered by the ops team as a container. The application teams have just to push their payload on top of the last layer of the most closed products they need. For example, if you are building a Java applications, you want to run on top of a Tomcat middleware, the idea is just to inherit a Tomcat image from the infrastructure team and push your own application payload on top of it to avoid reinventing the wheel from scratch. What is interesting here is Docker is also creating a new way to exchange technically between the people, because historically Docker comes from the ops world, because Docker at its early beginning it was something which was based on LXC. It was about copy and write file systems. It was just really ops technologies on top of which Docker pushed some APIs, creating a product with a way to operate it. But the point is, this product has interfaces and has paradigms which are fitting the dev point of view. It's not ops product for ops, it's a ops product delivered for dev public. And one point which is interesting is I manage the Docker community in Paris, and sometimes I ask the audience, who is developer, who is ops? We can ask the question today, who is developer here? And who is ops? That's the point. The point is, most of the people attending Docker events are often the developer because it is driven by the need. This is a product which fits their need. This is a product which speaks to them because it's something you drive through APIs, etc., etc. It's a product that application teams can embrace and use locally. Saying this, we now have an artifact, and we now understand that you must not push into the data. You have to ensure that we have a platform to run it. But the central question now is how I will deliver this. And that's the central piece of the continuous delivery with Docker. Well, at the beginning, you have this simple environment. We have a developer workstation. We have a software factory, which has been configured with some plugins I will detail just later. We have a Docker registry, which is finally a catalog of image we will use. And we have a platform on which we will be able to run our images. It can be something you can build up locally, a Swarm cluster, for instance, but it can be also a cloud provider. At the early beginning, the first place where Docker is used is locally on the developer workstation, because the really early environment in which the developer is testing his application prior to push its code in the repository is testing the application locally most of the time. And here, using a Docker toolbox, the developer is now able to pull a standard image from the catalog, push his own application in it, and test this application prior to commit anything without having tested first. So this is the first point. This is also the place where the developer will write the Docker file, which is the guidelines, the technical guidelines, say, to build the new version of the Docker image, enclosing the application on top of the base image on top of which he wants to rely. When it works locally on his own machine, the developer pushes codes as he does traditionally. But what is new is, in an infrastructure as code manner, is also pushing in the same way the Docker file, which is the document, the technical document, enabling to build an image on the Docker on the continuous delivery platform. The platform will detect that the code has changed. It could be the application code, but it also could be the Docker file code describing the application image. It detects this, and it starts doing something traditional, which is building the application, pass unit test, etc., etc. But then it has new tasks to achieve. It will pull in the registry the base image in which the application will be enclosed. It builds a new version of the application image. So for example, if your base image, which was in the registry, was a Tomcat instance, it will add the var containing the application it just built before. It configures the middleware, for example, the server XML in a Tomcat server instance. And when it's finished, it pushes back this new image in the Docker registry. What is interesting here is the Docker registry has now two roles. It's deliver a catalog of infrastructure image services, a Red Hat image or a Debian image, but it also now contains application artifacts, because in this way, the Docker container is now reflecting a built product ready to run. So it's taking the role that Nexus, Artifactory, and this kind of tools had in the past. Please notice that some of these tools, like Artifactory, are now taking some new features in order to act like a repository for Docker images to still be in the picture. Once the application image is pushed back in the registry, it's time to move to the second step of our pipeline, is to deploy this container application on the platform. It's doing so just through ordering the CaaS platform to run an instance of this container. The point here is no humans has interacted with the platform since the developer has committed his code. The idea is this first environment, the developer environment, is automatically pushed up to date with the last version of the application each time a developer has committed a new piece of code. So the teams have at any time the last version of the application working, which has passed the unit test and which is working to be able to test it rapidly. When it's time to move forward in our pipeline, let's say moving to UAT, we are doing the same. The platform will just order to the CaaS platform to pop up a new instance of the applications through the container it encloses. And the point is, you are running here the same image. It's really important to understand that we do not want to rebuild a new version of your Docker image per environment. This to avoid to have differences of the setup on the various platforms you are using. So you will be able to test at a really earlier stage if there are problems on your application. You will no longer have to face with problems on your production because the production was different from the development environment. This is the same because the container now encloses the application and all its subsequent infrastructure. So the middleware, the configuration, everything is the same from developer to production. When it's time to move to production, that's the same story. We are just ordering the platform to deliver the last version of the application, and the human action is only to tell, I want to deploy the application on this platform. So we have made the application, we have made, the developer having the real interesting role to decide whenever you want to move forward. You no longer have to act as a robot doing the stuff manually, configuring, deploying, etc., etc. Well, that was theory. But here you can see a screen capture of the result of such a platform when you are using it operationally. You can see here 3 versions of our pipeline. In the last version of our pipeline, we can see that we have an application which has been built because a new version of the code has been committed. It has been built, it has been tested, and it has been automatically deployed to development right after the build. We can see directly that the name of the container is here, game of life, but the tag, the version of this container is directly linked to the hash of the commit, the Git commit, which has been done when the developer has pushed his application. We can see also that to move forward to the next step, the operator just have to do one thing, is just to click on this button to decide to move forward. We can see that the previous version of the pipeline, which has been instantiated, is just a step later. It has been, the user has clicked on this button, and so it has been deployed up to UAT, but it's not on the production yet. And the older version of the application had been pushed up to production. So in this context, we have the last version of the application, which is on the development environment. The next version, which is ready in UAT, ready to push to production, and the last version, which is only at the development stages for the moment. To do this demonstration, I use, in fact, the following tools, but it's not the only possibility. You can use some other tools to achieve the same thing. In this demonstration, I use the Docker toolbox to enable the developer to create the Docker file, which is reflecting the configuration of the container locally on its workstation. I use also a GitHub repository to contain the application and the Docker file code. In this way, I have correctly merged the application and infrastructure lifecycle, because this Docker file contains two things. It contains the orders to deploy the application on a container, but it also explains which version of Tomcat I want to use, which version of the configuration, etc., etc. So everything has been merged as a code. Jenkins is still there to build up the application, pass unit tests. I installed on it the delivery pipeline plugin to have the view you had just on the slide before. And I use the cloud-based plugin, which was used to make Jenkins able to control Docker action. In fact, it was used to tell Jenkins that it orders a Docker build to create a new version of the image, to push it on the registry, and to deploy it on the cluster. And on the screenshot, I was using the IBM Bluemix platform, but you can put anything you want, which is facing Docker APIs. For example, you can use a Swarm cluster. It will work exactly the same way. At this moment, we just managed a single application artifact. But the point is, an application is not only made out of one artifact, one binary. Most of the time, you have several parts of your applications, especially when you are achieving fine granularity with microservices. But it also means that your applications may have a database, a RabbitMQQ or something. The application is a whole topology enclosing several services. What is interesting with Docker now is, for a long time, it has been centered of the container paradigm we just discussed before. Now, it's quite different, because the containers are still there, obviously, but they push some new features in the picture, which are now enabling to handle all the things you need to make your application running. It means there are storage which is managed through the Docker volumes. It is a feature enabling to export the data outside the containers, backing them, for example, in Amazon S3 or Ceph or different kind of backends. There is also the network, which is now handled through the Docker network services. You can create SDN networks, overlay networks, and to finish, the most important piece, you have also the topology, which is enclosed in a file, a YAML file, describing all the containers, all the stuff contributing to the application topology. For example, in an application, should you have 3 instances of a middleware, a database, a queue, all of this is described in this topology, which is also a piece of code, so it could be versioned also. All of this describes the whole application picture. And so the next step is not only to push in the pipeline we saw before just the application artifact, and you would still have to push all the pieces together to make your application working. The idea would be to push in your pipeline the whole topology of this application. And you can do this, for example, using the Jenkins platform to trigger the deployment of topologies with using the Docker Compose tool, which is the tool which is used by Docker to read this topology descriptor and to control the CaaS platform to deploy all the artifacts. All of these objects, which are finally reflecting all you need for the application, are reflecting on what you need for the application. And also, Docker provides now everything you need to push your application on top of this platform. So you have the Docker engines, which are enabling to host the clusters, the Docker containers on top of it. You have also clustering to have a logical view of several Docker instances. You can provision new Docker servers to join this cluster using the Docker machine tool. And you have the registry, which is the product which is aimed at hosting your Docker images. Well, at this step, we have a picture in which you are able to deliver not only a single application artifact, but a whole topology through this pipeline. The point is, Docker means a lot of things at the same time. It's first the container artifact we just saw before. This container artifact contains the application and all its subsequent infrastructure. It's something which is really self-sufficient. Docker, it's also about cloud topics, because we saw that once you have containers, you have to host them somewhere. So you can create your own platform, you can leverage on cloud services vendors. Docker, it's also about DevOps stuff. What we discussed just before is, well, it's not only technical stuff, it's how do we collaborate all together around this point. We saw that the container contains both the application and all its underlying infrastructure. So you can no longer split the people which are in charge of the applications on one side, and the people which are in charge of infrastructure, delivering middleware, etc. on the other hand. These people must collaborate closely all together to make the application container being able to run correctly. It's also not about organization, it's also about architecture. Because in fact, a point which is important is to take the best of Docker. Your application should fit the appropriate paradigms for it. For example, if you want to have an application which is scalable, and in the Docker world, it is something which is simple to achieve. Having an application which scales horizontally, it's just about running several instances of the same container. But to make this working simply, it means that the architecture of the applications is thought for this. It means that it does not handle sessions, or ideally. You must provide stateless services in it. It means that the application has some service discovery and making all the sub-services of this application working all together, etc., etc. So to take the best of breed of Docker, it's not about only enclosing your traditional app into it. It's also about shaping your application to fit the Docker paradigms most elegantly. Finally, it's also about continuous delivery, because what we saw is once we can push our application in a container, the idea is to deliver this container the most rapidly possibly. At the end, Docker is full of possibilities. It enables to get some time to market, because in this kind of scenario, we have automated almost everything from the Docker, from the code push on the platform up to the delivery of the application on production. It's about quality also. I insisted just before about the fact that the application artifacts, the images we are building for an application, is the same which is run on the various environments of your pipeline. On development, on UAT, on production, it's always the same artifact. For the same reasons that you are not building a new version of your code for each environment. So you ensure that what you are doing is something repeatable, which is something which will have the same behavior on all the environments you will run your application onto. Finally, it's an opportunity to save costs, because in Docker you are isolating your whole application on the server. So it means that you can push more and more applications on the same server, and since the most important part of a server is not the hardware, but all the management, I mean patch management, monitoring, etc., etc., etc. When you are mutualizing not only the hardware like you are doing in virtualization, but everything related to the servers, I mean the patch management, the monitoring, etc., etc. Well, it lowers the cost of your platform, because you can push much more applications on the same server assets. So this aggregation of the resources is also the opportunity to save time. Finally, I've not pushed this in the presentation, but since the containers are portable, the point is these containers are agnostic from the platform on top of which they are running. It means that you will be able to have your assets on your local platform, on your local servers in the first step. And if you want to move progressively to the public cloud, you can imagine redeploying your application containers directly on the cloud without further changes in the applications. So it's really the opportunity to have a transition to the public cloud easily, smoothly, and transparently from the application perspective. It also enables to have some hybridation. You may imagine having a platform hosted locally, for example, a Swarm cluster, having nodes which are local servers, but also having nodes of the Docker clusters which are servers which come from Amazon, Azure, or other providers. The point is, you can have a logical view of your Docker farm, which is running servers from different vendors, and you can push your containers on top of each of them. And so it could be really useful for applications which are having a load which is changing across the day. For example, we studied applications having an important load the morning and a lower load the afternoon every day, because it was requiring a lot of computation. The idea was to ensure that the application has enough instances working in the cluster on the morning and reducing the amount of instances the afternoon. So it was the ability to scale automatically. But the point was to save costs. The idea was to tell, we will have an internal capacity enabling to host a certain number of containers, but when we had some peaks for this morning load, we would provision additional servers from public cloud, push containers on top of it, and then decommission these servers when they are no longer used. So it means that your application scales, but the container platform, the CaaS platform, also scales. You can change the number of nodes depending on the use you have. Well, I thank you for this presentation, and I'm here to answer any questions you may have. Yes? Hmm? Mm-hmm. Yeah, because in fact, Jenkins still have the original use you had previously. So it means that Jenkins, through webhooks, for example, with GitHub, it will be able to detect the code change, having the traditional operations he managed. I mean, building the applications, passing the test, and you can put some rules and deciding whenever you want to move forward or locking, because, for example, it does not pass the unit test, etc., etc. And depending on these results, you will move forward in the pipeline or not. So, for example, the development environment we had in the presentation just before was only deployed when the application code was being able to be built, obviously, but also when all the unit tests and any kind of tests you wanted to push at this stage were correctly passed. Yeah, it's about Jenkins configuration. In fact, in this world, we are just using the CloudBees plugin to add a last post-build step, which is responsible for building a new Docker image and pushing it back to the registry. So it does not really change this part of the Jenkins original role. In fact, there are several ways to answer this question. The point is, at this time, Docker does not directly manage scalability. So it means that if you want to use Docker native tools, you can use Docker Compose to inform the Docker cluster to add or reduce the number of running instances of an application, but it will not decide whenever to do it. So you have to create something to be able to decide what you want to have as a strategy. But if you're using Kubernetes or other kind of tools, you will be able to do this in certain conditions. For example, most of the tools are able to detect that CPU is highly load, so it means adding some new instances to run. But that's really low level KPI which are used to decide. To make something really more efficient, it's important to be able to create something which will be able to understand the application status. For example, the example I have in mind, there was a queue having some objects, some calculation portfolios to process. The idea was when there are more calculus to achieve, it means that the queue is growing because you do not have enough nodes to take the portfolios, calculate them. The queue is growing. So the idea is more to be able to detect that the queue is growing, to instantiate new nodes, to be able to reduce the queue size. But you can't do this easily with Kubernetes or other kind of tools because you must have in mind the architecture of the application itself. These tools cannot know that the application of your application, that the architecture of your application have a queue and that the size of the queue is an incentive to decide your strategy. So I think at this time, yes, Kubernetes and some tools have the possibility to decide whenever to add or reduce some nodes, but the incentives which are used for this are quite limited. So it's more interesting to add something particular, to have more interesting incentive to use to decide whenever you want to scale up or down. Again, this is something you have to add because in fact Docker will not be able to do this natively. It depends on several stuff. One of the points is the bandwidth is changing, but you may still have pending sessions opened on containers which apparently no longer have some traffic. You may have particular conditions you have to understand to decide whenever you want to trash these containers to move back traffic to the other containers. It really depends on the application architecture at this time. So this is something that Docker will not address directly. This is something you have to add because it's really related to your own application architecture. Yep. We had not issues up to now, but we hadn't really specific use cases to address. That's right, that in some way, multicast or other stuff may be something we have to focus on because I don't know if it works natively or not. A priori, it should, because in fact, a Docker container has its own interface. You may wish to bridge it directly to the real network without having to NAT or something with the host. So a container can have its own network stack, and so it means that theoretically, multicast, for instance, should not be a problem. But I do not have any clue for this. Do you have some other questions? Yep. In fact, I think that this kind of tools should be, it's quite difficult because some of these tools can't be automated easily. So sometimes it's difficult to integrate this in these figures. In this situation, I think the idea is more to make the pipeline deploying the application at a stage, managing this out of band, and then when the tests, etc., are run and the results are positive, then you decide manually to move forward to the next step. But anyway, Jenkins or the other kind of tools are achieving the same thing, have APIs, etc., etc. You may imagine to use these APIs to trigger the next step automatically, better than having a button for this. So the point is the ability to integrate these kind of tools programmatically, in fact, with the continuous delivery platform. Other questions? Okay, thank you.